Hello, in this video, we are going to be solving an advertising mix problem using Solver in Excel. In a previous video that I just recorded, we walked through the process of listing out the objective function and all of these constraints. So we have as variables the number of dollars to spend on search, display, YouTube, and Facebook ads, S, D, Y, and F. We are trying to maximize the return on our investments. And in the previous video, we calculated the return on investment for every dollar spent for each of these four options. And then we had these 8 constraints. And the first constraint says that the total amount we spend has to be less than or equal to 20,000. The next 2 constraints say that the display and the search ads have to be at least 2,000. And then almost all the rest of these are requiring that certain things be more than the total or less than, more than half the total, or at least 10% of the total. Except this one here, number 7, ensures that we will receive at least 3,000 orders as a result of this campaign, if possible. I mean, it's always important to note that we're just writing down a wish list here before we solve the linear program. And I mean, hopefully this all works, but I mean, your boss can say, okay, you can spend $100 and we need at least 1 million orders. And we could write the linear program, and then the solver is going to tell us, sorry, that does not have a feasible solution. So I am not going to talk about the details of how we came up with this formulation, because that's what the other video is for. There'll be a link at the bottom. What we're going to do here is we are just going to put all of this into Solver in Excel. And the important thing to note here is that I have followed good practice, and I have lined up all of my variables in standard form, so it's easy to keep everything straight. Now, in a perfect world, I would switch back and forth between the view of my piece of paper here and my view in Solver in Excel. But the reality is it just takes a few too many clicks. It's a little bit clunky. So what you honestly might want to do is pause the video right now and take a little screenshot of this linear programming formulation so that you can refer to it as I'm going along in Excel. All right, so let's go. Let's see, let's go back for you the first time. So this is the information that I started with to write up the linear program. And just to keep things simple, I'm going to just actually, I'm going to just start on a new sheet. Okay, so our goal is to maximize return on investment. And I'm going to put the return on investment coefficients for each of the variables here across the top. So it's 15.1, it's 2.5, it's 6.7, and it's 32.8. And then these are search, display, YouTube, and Facebook. And so those are the objective function coefficients. And then below them, those cells, I'm going to put the numbers, the decision variables. And I like to just have some number in there so that while I'm building my spreadsheet, I can verify that the spreadsheet seems to be working the way I expect. And then I like to highlight that in yellow because that way it's easy to find. That's the decision we're trying to decide how much to do. Our objective is to maximize the return on investment, as we've said. And the return on investment is just $15 for every $10, times $10 here, 2.5 times 10, et cetera, et cetera. But anyone who knows me knows my favorite Excel formula is sum product. And so I'm going to type sum product, and then I'm going to highlight those 4, and I'm going to type a comma, and then I'm going to highlight these 4 while holding down Shift key, and then type the right parenthesis, and there's my answer. Then I'm going to press F2 just to, actually I'm going to move this over one spot. I don't want it. And I'll press F2 just to make sure it's working right. And sum product is great because it's just taking all the red boxes, multiplying them one at a time times the blue cells, and then summing those products to get our final answer. And then this obviously is a really important cell. That's the reason we're doing it. So I like to do something to highlight it. Maybe that's not good enough. Let's make it blue. Great. So then we have a series of constraints. Let's see. So number one was the budget constraint. And number one says S plus D plus Y plus F has to be less than or equal to 20,000. So the coefficients in front of those variables, it's just one. 1 times S plus 1 times D plus 1 times Y plus 1 times F. So we'll just put 1 as the coefficient for each of those. And then here we go, back to my friend and hopefully soon yours, sum product. And so I typed it in the left parenthesis, and then I just use my arrow key to go to the left and hold down shift to get those, and I type a comma, and then I'm going to go up here and press shift and highlight these. And now I'm going to hit F4. That's going to lock those cells in absolute reference mode so that it's, I can reuse this formula in just a second. So with my definitely not right answer so far, spending $10 on each option, I would be spending $40 total. And that is definitely less than or equal to 20,000. For future use here, I'm going to set this as using comma format. So when we get bigger numbers, we've got commas, so it's easier to read them. All right, so that 40 has to be less than or equal to 20,000. And then I'll move that box quite that wide, so it's a little easier to see what's going on. Okay, so that was our budget constraint. Number two is a display spending constraint. I'm not going to write very long descriptions of these constraints, but I will number them. So if you want to go back and reference the constraints from the earlier video. So for this constraint number two, all it says is that D has to be greater than or equal to 2,000. So I need a 1 in the D column, and then I need greater than or equal to 2,000. Number three is the search minimum requirement on the search, and all that says is that S has to be also greater than or equal to 2,000. I realized I was so excited to type the next constraint that I didn't fill in these boxes here about how close we are to satisfying that constraint. So let me go back up here to cell G5, where I put sum product and I have the dollar signs in front of the numbers in the red cells. I'm just going to copy this, Control C, and then I'm going to paste it, and then I'm going to paste it. And you can verify that, okay, let's change these numbers. We'll do different numbers, 10, 20, 30, 40. So we can verify the display adds 20 here, and it's 20 there. It's definitely not satisfying the constraint, and it's not more than $2,000. The search adds 10, also that does not satisfy the constraint. All right, number four, this is one about having search and having YouTube and Facebook be at least 50% of the total. But for now, all that matters is that the coefficients are -0.5 and -0.5 and +0.5 and +0.5. And so seeing what the result of that sum product is 20, and the constraint says that this has to be greater than or equal to 0. Constraint number 5 is that Facebook has to be greater than search. And so the coefficients there, we have a -1 in the search column, and then we have 1 in the Facebook column, and that has to be greater than or equal to 0. Copying that formula down, 30 is the net result of that, and that's greater than or equal to 0. Number 6 is the one that says that search has to be at least 10% of our expenditures. So we have 0.9 in the search one, and -0.1 in the display one, and -0.1 in the YouTube one, and -0.1 in the Facebook column. And that all adds up to 0 at this point, apparently, and that has to be greater than or equal to 0. Number 7, let's see here. This is the minimum sales constraint. We have 0.16s and 0.05 display and 0.37 YouTube and 0.75 Facebook. And look at that. It automatically put the formula in there for me. Let's see if it, yep, some product, that's good. And this has to be greater than or equal to 3,000. Now, number 8 is another one of those 10%. I think this is YouTube. YouTube has to be at least 10% of the spending. So we have minus 0.1, and then we have minus 0.1, and then we have 0.9, and we have minus 0.1, and put in the formula, that's handy. And this has to be greater than or equal to 0. Now, we should be ready to solve it. But I don't have a live studio audience here, so I'm a little nervous because honestly, the odds are good that I made some kind of mistake somewhere along the way. And you may be watching the video thinking, no, that's not right. But unfortunately, I can't hear you right now. So pardon me a minute while I just go back and look through this. We have 15, I'm looking at 15.1, 2.5, 6.7, 32.8. And then we have 1, 1, 1, 1, and then D is 1, and then S is 1, minus 0.5, minus 0.5, plus, minus F, plus F, 0.9, minus 0.1, minus 0.1, minus 0.1, 0.16, 0.05, 0.37, 0.75, minus 0.1, minus 0.1, 0.9, minus 0.1, and then this is less or equal to 20,000, greater than 3,000, 0. And then number 5, I wrote it originally as greater than. One assumes greater than or equal to would probably be just fine as far as our client or decision makers are concerned. Number 6, greater than or equal to 0, greater than or equal to 3,000, and then non-negativity. Okay, if there are mistakes, I missed them. Let me hide this little meeting control, and now we are ready to solve this thing. Once I save it. So let's go to data. Let's go to solver, and let's get this party started. Now, our objective function is this cell right there, G3, and we are trying to maximize, and the variable cells to change, those are the ones there in yellow. Now we're ready to add our constraints. So let's do that. So the first one says that number has to be less than or equal to this number. And then all of the rest of these are greater than or equal to. So I'm just going to highlight all the greater than or equal to again. When I wrote the problem, I said the one was greater than, but I'm just going to treat them all as greater than or equal to. I mean, it seems sort of silly. I think, oh yes, at least one more dollar on this one than that. So greater than or equal to seems like it should be fine. So now we need the right-hand sides. Highlight those. Click OK, because that's all of them. Then the make unconstrained variables non-negative box was already checked, which is great because that's exactly what we want. And then we are going to use the simplex algorithm for this. So let's see what happens. You found a solution. Hooray! We have the answer report, the sensitivity reports, and the limits report. Let's check each of those out in turn. But first, let's go up here and see what the optimal answer was. Let's put some commas in there so we can make sense out of it. So spending $2,000 on search and on display and on YouTube and most of the money on Facebook. Which, again, since we're maximizing return on investment, and Facebook by far has the highest return on investment, it's no shocker we spent most of our money on Facebook. And we were only doing the minimum here as required by the display and search constraints of 2,000 exactly. Our other constraints obviously must all be satisfied, or it wouldn't have said it. Came up with an answer. So let's look at the reports. So answer report, it took the simplex algorithm 10 iterations to find its answer, and which on this laptop, which is working hard recording this video, took 1/100th of a second. Total profits would be $500,000, $1,800. And then we know the amounts to spend in each category. We can look at our constraints. The budget constraint is binding the display, and search budget constraints are also binding. The 50% constraint saying that Facebook and YouTube have to be at least 50% was not binding. Why is that? Well, because we spent so darn much money on Facebook that anything involving Facebook is going to be more than half the total. Facebook being more than search ads, again, not a problem, not cramping our style, so that is not a binding constraint. Search has to be at least 10%, that was binding, and then YouTube has to be at least 10%, that was binding. The minimum number of sales, we had to get at least 3,000 units of sales, and we're getting 11,660, so yeah, that constraint was not a problem. So if you look at this YouTube being at least 10%, that's why YouTube was 2,000. We're spending $20,000 and YouTube has to be at least 10%. So we have to spend at least 10% of 20,000, which is of course 2,000. And that's why YouTube ended up being 20,000. So that is our answer report. Let's jump to the limits report because I just don't really have any use for this. I don't see what provides us any valuable insight here. So moving on. Sensitivity report is perhaps got something interesting for us here. We can see how much we spent on each one. All of these variables are non-zero, so the reduced costs are zero. We have the objective coefficients for each, and the return on investment for search is 15.1. If that were to decrease by a gazillion dollars, Excel speak for a gazillion dollars, one with 30 zeros. You could decrease that as much as you want, and it would still be optimal to spend $2,000 on search. Same thing is true of the display ads. YouTube, it could decrease from $6 all the way down to negative $295 before it would be optimal to not spend $2,000 on YouTube. Facebook, however, it's optimal to spend $14,000, and the ROI is 32.8. If that were to decrease by 17.7, the answer would change. And how does that make sense? Well, if it's at 32.8 and it decreased by 17.7, that would take it down to what? The objective coefficient, the ROI would be 15.1. Oh, that's exactly the objective coefficient on search. So that's where that came from. So if the profit for Facebook ROI were to go down to 15.1, then it wouldn't be optimal to spend so much money on Facebook. And then similarly, if you look at these increases on these other ones, basically if they increased enough so that they were as profitable as Facebook, then it would be optimal to change our answers. So this is the optimal answer, and these other ROIs would have to really increase, or Facebook would really have to decrease before this would no longer be the optimal answer. So this is a very robust answer. It's not like this answer would really change a lot if one of those objective coefficients were to change just a little bit. Looking at the constraints, the budget constraint is tight, as we saw on the binding, as we saw on the previous page. And the shadow price is $30, meaning if for every additional dollar in advertising we are allowed to spend here, we'll generate $30 net sales. So that's good to know. If you want to make the argument to somebody that we should spend more on advertising, here you go, right there. Although that's not robust for a very large increase. That's a very small number. But as far as the decrease goes, if you took money away, you'd lose $30 for every dollar you took away. The display ads, we're forced to do at least $2,000. Every dollar you would increase that by would reduce our total sales by $30. Similarly, for the search, every additional dollar you force me to spend on search is going to result in $17 reduction in sales. This 50% constraint is zero right now. And on that, these percentage constraints are a little wonky to try to get an intuitive feel for. So I'm really not going to say much about it other than we would have to increase the right-hand side by a lot before it affected us. We could decrease it by a lot before it affected us. So those constraints aren't, our answer would not change a lot. We'd have to change these constraints a lot before the answer would change. Then the minimum sales constraint, we're selling 11,660 units. The constraint said sell at least 3,000, so we're way beyond that. So that's what we can learn from looking at these. This is sensitivity report. So to go back here and to wrap things up, we created started with a blank spreadsheet here. We made these yellow boxes to represent the quantities to spend in each category. We put the return on investment numbers for each category above them. We used some product to calculate the total expected return on investment from all this spending. And then we entered the constraints, the budget constraints, the display constraints, the search constraint space constraint, and then all these other constraints using formulation that came up in the previous video. And then we solved them. And if we were told we needed to make any changes in the constraints, we could go make them and run it again. And programming finds the answer for us. I hope this has been helpful.